Hello everyone, welcome to the video lecture series on Z transform. In this video lecture, I am going to discuss two standard formulas which are here. First formula I am going to discuss is the how to find the Z transform of a raised to n over n factorial. Let us see how to handle it. The first step over here is that we consider our sequence f of n equals to a to the power n over n factorial. After that, what we will do is we now use the definition of Z transform. So this is the definition of Z transform. Now here we plug up the sequence f of n, that is a to the power n over n factorial. We plug it up over here. Now this answer for this sequence is e to the power a by z. Now let us understand how do we get this. Here what we need to do is, in this series that we write, okay, this can be simplified a bit further in this manner: summation a upon z whole raised to n divided by n factorial. This can be written in this manner, where n goes from 0 to infinity. Now we recall the series that we have already seen. The series of e raised to x, if when we recall this series, we have seen this series in our first prerequisite video lecture, that e raised to x can be written as x to the power r summation x to the power r over r factorial, where r goes from 0 to infinity. Now when we compare this series which we had written for e raised to x and the format that we are having over here, only thing is there we can see that instead of r we have n. Okay, n going from 0 to infinity. In the basic version we had seen r going from 0 to infinity, and here instead of x we have a upon z. Okay, so what we have to write here is e to the power a by z. Now this notation is slightly like, since in the power you have to write, so it looks, sometimes some students also make mistake, they write a by z. So sometimes we cannot distinguish whether it is absolutely in the power written, or sometimes mistakes can happen. Some students can write like this also, e 1 by z. So in order to avoid this confusion, what we do is we write this notation in a much better way so that no confusion gets created. What we write is, we write here in this manner: z transform of a to the power n over n factorial. This now we write e to the power a by z is exponential of a by z. Now the meaning is the same, e to the power a by z, but now the term which is in the power is exclusively written in the bracket. And now you have to remember that exp of a by z is nothing but exponential e to the power a by z. That's what you have to remember that. So this is our first formula, a standard formula that is always there. Now in this formula, if we substitute a equals to 1, we get a special answer here, that is if we write a equals to 1, we get z transform of 1 upon n factorial, which is exponential of 1 by z, which can be written like this: e to the power 1 by z. Okay, so this is the one of the special formulas that is always there when we are uh, solving z transform questions. Okay, so I'll just please make a note of all these things that we are seeing. Please first put this formula in the box. I'll So it is an important formula. I'll erase off all the terms. This is the formula that we have. Now let us move on to the second formula that we have to see. This is another important formula, Z transform of the sequence f of k, where the sequence terms are nck. Now what is nck? Nck is the combinatorial notation for choosing k objects out of n. So here, if you remember, in permutations and combinations we have this notation. Nck is nothing but n factorial divided by n minus k factorial upon k factorial, right? This is the notation we have. So what is the Z transform of this sequence if we have the sequence with this kind of term in it? So how to handle it? So let us see. First we consider the sequence f of k equals to nck. Okay, now observe your very important thing, that we have always taken our sequences f of n, but in this question k is the runner and not n. Okay, the runner is k and not n. So my sequence I have automatically written here, f of k is equals to nck. Now by definition, when I go, I get f of k equals to summation f of k into z to the power, by definition. So when I go by definition, z transform of f of k is equals to summation f of k times z to the power minus k going from 0 to infinity. I plug up the value for f of k and ck over here. I get this expression. Now we have very nice understanding coming into the picture. I can write z to the power minus k in this format. Okay, it can be written as 1 upon z power k. This is possible, and this one has a very nice freedom. What is the freedom with one? That one is multiplied to every number, and we can adjust the power of 1 as per our suitability. So I have adjusted this 1 over here. So this is a very important step according to me. So please try to understand this step, that this adjustment we have done. Now if you remember or recall the steps of binomial distribution or binomial expansion, so remember these steps over here, that z to the power minus k, I convert it to 1 upon z whole raised to k, and 1 is adjusted as per the requirement. Why this requirement has come? Because of binomial expansion formula. Let me give you what is the binomial expansion formula over here. Binomial expansion formula is this. It says if I have two terms, a plus b whole to the power n, if I want to do, then I can write this summation in this manner, nck. Okay, nck a to the power k into b to the power n minus k. This can be done, and where k goes from 0 to n. Observe here the formula for binomial expansion. It is absolutely the same what we have written, right? So you can write this way. Because of the binomial expansion, now I am in a position to write my terms in this manner. Okay, therefore z transform of f of k can be written as 1 plus 1 upon z whole raised to n, right? We can do this shift over here. Another, also there is one more version in this. You can just change the terms also. Instead of a you can have b first, and then instead of b you can write a. That is also allowed. So I get my answer over here. Z transform of f of k is equals to 1 plus 1 upon z whole raised to n. So this is the z transform of nck. So these are the two important formulas that I wanted to discuss with you. I hope you liked the video lecture. Please hit like and share it with your friends, those who find it useful. I shall soon see you with the next topic of Z transform in the next video lecture. Thank you.